Section 6.4, Solving Equations by Factoring. In the last section, Section 6.3, we learned all kinds of ways to factor. In Section 6.4, we're now going to solve. Very different things, but solving does involve factoring. Now on the test, be careful. I will ask you to factor some problems, and I'll ask you to solve others. So make sure you know the difference between factoring and solving. So, to solve quadratic equations by factoring, the first thing you want to do is make sure that the equation is in standard form. Standard form says we have ax squared plus bx plus c equaling 0. The main thing in step 1 is just to make sure that your equation equals 0. Step 2 is you're going to factor using any method from 6.3. So we had a lot of different ways that we learned to factor. They're all going to come into play in this section as well. Now here's the new step. The new step with solving is you're going to use something called the zero factor theorem. Now what does the zero factor theorem state? It states that if a times b equals 0, meaning if you're multiplying two things and they equal 0, then either the first thing has to be 0 or the second thing has to be 0. And it doesn't just have to be two things, it could be 3 or 4. But if you're multiplying a times b and it equals 0, then either a has to equal 0 or b has to equal 0. A and b do not have to be monomials, they could be binomials. So make sure you understand that it's those factors that equal 0. So step 4, we're going to solve. Now how do we solve? Once we set each one equal to 0, it should be a linear equation, so you should be able to get the variable by itself and solve. The last thing is we can check by substitution. So the great thing about this section is that you can actually make sure all your answers are right by substitution. So let's look at some examples. Solve. Number 1, x parentheses x minus 2 equals 0. So if step 1 says does the equation equal 0, and it does. Step 2 says to factor. Some students want to multiply in the x, but if you look closely at number 1, it is already factored for you. So step 3 says use the zero factor theorem. You have things being multiplied that equal 0, so either the first thing, which is x, has to equal 0, or x minus 2 would have to equal 0. And then we'll solve each resulting equation. Well, x equaling 0 is already solved. And on the second one, we'll need to add over the 2, so x would equal 2. So I do have two answers, x equaling 0 and x equaling 2. You can leave them separated or you could put them together. Just make sure you separate with a comma. Don't put parentheses because it's not an ordered pair. They're just two separate x values that work. So the last step is to check by substitution. I'm going to check x equaling 2 and I'll leave you to check x equaling 0. So how do we check? Well, we go back to the original problem, which is x times x minus 2 equaling 0. And I said I would check x equaling 2. So what we do is we plug in a 2 wherever we see x. We'll plug in a 2 there and a 2 there. So anytime I do a substitution, I use parentheses. So parentheses 2 and then 2 minus 2. Well, that gives me 2 times 0, and 2 times 0 is 0. So it does check. So go ahead and try checking x equaling 0. Looking at number 2, parentheses 3x minus 1 times parentheses x plus 9 equaling 0. Following the steps, the first step says does the equation equal 0, and it does. The second step says to factor. Well, this one's already factored for you. If you multiply it all out, you're going to have to refactor. So just notice that it is already factored for you. So step 3 says use the zero factor theorem, which states either 3x minus 1 would have to equal 0, or x plus 9 would have to equal 0. Now these are linear equations, so we need to go ahead and solve them. On 3x minus 1 equaling 0, we would add over the 1. So 3x is going to equal 1. Divide by 3 on both sides, so x would equal 1/3. In the other equation, we're just going to subtract over the 9, and x is going to equal -9. So my two answers are x equaling 1/3 and -9. You may leave them separated or you can put them together, just separate with a comma. We could check our answers, but to save time, I'll let you go ahead and do the check stage on your own. Number 3, x squared plus 6x plus 5. following the steps, the first step is to make sure that the equation equals 0, and it does. Second step is to factor. Well, looking at x squared plus 6x plus 5, it's a trinomial, and what's in front of it, the x squared, is a 1. So we know this is the C method. So we just need factors of 5 that add up to 6. And the factors of 5 that add up to 6 are 1 and 5, because when I multiply 1 times 5, I get 5, but when I add, I do get 6. So this was that quick way, because it was a C method where we can jump to our answers of x plus 1 and x plus 5. So those are our factors, and now because we're solving, we're going to set each factor equal to 0. So either x plus 1 would have to equal 0, or x plus 5 would have to equal 0. So solving each resulting equation, we'll subtract over the 1, so x would equal negative 1. And we subtract over the 5, so x would equal negative 5. So x is going to equal negative 1 and negative 5. Again, we can check our answers by substitution. So looking at number 4, we have x squared plus 7x equals 18. So as we noticed, the first step was that we needed a 0 on the right-hand side, which we do not have. So we need to subtract over the 18 to bring it over to the other side. When we do so, we get x squared plus 7x minus 18 now equals 0. So at that point, we would need to start trying to factor. Again, the number in front of x squared is a 1, so we know it's a C method. So we need to find the factors of negative 18 that add up to a positive 7. Factors of negative 18 that add up to a positive 7 would be negative 2 and positive 9. So putting those into the factors, we're going to get an x minus 2 times an x plus 9 equaling 0. So at this point, we were going to set each factor equal to 0 so we could solve. So either x minus 2 would equal 0 or x plus 9 should equal 0. So once I solve those out, I end up with x equaling positive 2 or x equaling negative 9. Number 5. First step first is to make sure we have a 0 on the right-hand side, which we do. The second thing is to factor. Well, what's the first thing we always look for? We look for GCF. Is there anything in common between an x squared minus 6x equaling 0? Yes, there's an x in common. So I'll take out the x, and I'm left with x minus 6 equaling 0. So this should look like the first example, where it was already factored for you. After we factor out the GCF, we are factored form. It does equal 0, so now we'll either set x equaling 0 or x minus 6 would have to equal 0. X equaling 0 is already solved for you. We'll add over the 6 to the other side for the second equation, and x would equal 6. So our two answers are x equaling 0 and 6. I'll let you do number 6 on your own, but I will start you off. It does not equal 0, so the first thing you'd want to do is subtract the 8x. Those are not like terms, so it's just going to be x squared minus 8x equaling 0. It's going to look a lot like number 5, so my final answers are 0 and 8. So x equaling 0, comma 8. Number 7. X squared equals 14x minus 49. So the first things first is we want to make sure we have a 0 on the right hand side, and that is not true. So I'm going to subtract over the 14x and then add over the 49. Now why would I not just bring the x squared over to the right hand side? I could, but that leaves my x squared being negative, and I really like to factor with the coefficient of x squared being positive. So since x squared is already positive on the left hand side, I'm going to go ahead and bring over the 14 and bring over the negative 49 instead. So I get x squared minus 14x plus 49 now equals 0. So since it equals 0, the next step is to try and factor. This is just a C method because the number in front of x squared is 1. So I need the factors of 49 that add up to negative 14, which would be a negative 7 and a negative 7. When I multiply two negatives, I get a 49, but if I add a negative 7 and a negative 7, I get a negative 14. So to factor into x minus 7 times x minus 7 equaling 0. Setting each factor equal to 0, since it's the same factor, I'll only set one equal to 0, and I'm going to add over the 7, so x is going to equal 7. So we only got one answer there. You'll learn more about multiplicities when we get into college algebra, and that just means that you saw that factor appear twice. Don't need to know that, but that's going to be kind of important when you get into college algebra. Number 8, 3x squared equaling 15 plus 4x. Well, again, we see that we do not equal 0. So I need to bring over the 4x and bring over the 15 by subtracting. Make sure you put it in descending order. So it's going to be 3x squared minus 4x minus 15 equals 0. So make sure you get it in descending order. So now that we have the 0 on the right hand side, we need to figure out how we factor. Well, since the number in front of x squared is not 1, it's a 3, we know we need to do the AC method. So I'm going to skip the steps. You're going to do the AC method, which is a lot of work, and then make sure you get the factors I get. So it should be factored into x minus 3 times 3x plus 5, again equaling 0. So again, this is the AC method. Takes a lot of work. If you have questions, let me know. So then I'll set each factor equal to 0. So x minus 3 should equal 0, or 3x plus 5 should equal 0. And then I'll solve each individual equation. I'll add over the 3, so that gives me x equaling 3. On the other equation, I'll subtract over the 5 first. I'll get 3x equaling negative 5. Divide by 3 on both sides, so x would equal negative 5/3. You can leave them separated, or you can put them together as an answer. So my answers would be x equaling 3 and negative 5/3. Number 9, 9x squared minus 100 equals 0. So this is a binomial. Well, it does equal 0, which is great. It's still quadratic because we have an x squared. Now we got to figure out how do we factor this. Well, with a 9x squared minus 100, it's a binomial. It's going to be a difference of squares. So that formula a squared minus b squared is a plus b times a minus b. So now we just got to figure out what are the things that are being squared. Well, what can I square to get 9x squared would be 3x, because 3x times 3x is 9x squared. What can I square to get 100 would be 10, because 10 times 10 is 100. So this is going to factor into 3x plus 10 times 3x minus 10 equaling 0. So then I'll need to set each of these factors equal to 0 and solve. So either 3x plus 10 would equal 0, or 3x minus 10 would equal 0. Solving each equation, I would subtract over the 10 on the first one, and I'd get 3x equaling negative 10. So x would equal negative 10/3. On the second one, I would add the 10 over to the other side. So I get 3x equaling positive 10. Divide by 3 on both sides, so x would be equal to a positive 10/3. All right, number 10. X parentheses x minus 3 equals 18. It almost looks like it's factored for us. However, to use the zero factor theorem, we need it equaling 0, not 18. So even though it looks like it's factored, we really can't use it in the form it's in. So this is where I do need to distribute in the x and bring over the 18. However, if x parentheses x minus 3 would have equaled 0, then I'm ready to go with step 3. But it doesn't. So we'll go ahead and distribute the x, and we get x squared minus 3x. I need to subtract the 18 over to the other side, and it's going to equal 0 now. So at this point, I need a factor. Looking at x squared minus 3x minus 18, I see that this is just a C method because the number in front of x squared is 1. So I'll need to find the factors of negative 18 to add up to a negative 3. And that would be a negative 6 and a positive 3, because when I multiply, I get a negative 18, but if I add, I get a negative 3. So this would factor into x minus 6 times x plus 3 equaling 0. So set each factor equal to 0 and solve. I'll skip a few steps. My answers would be 6 and negative 3. Number 11. Parentheses x minus 3 times x plus 8 equals negative 30. Again, this looks like it's factored, which is really nice, but the problem is it doesn't equal 0. It equals negative 30. So we're going to have to multiply that all out, bring over the negative 30, and go ahead and start factoring. So Let's FOIL. X times x is x squared. Outer would give me a positive 8x. Inner would give me a negative 3x. Last would give me a negative 24. And it equals negative 30. So combining like terms, the positive 8x minus 3x would be a positive 5x. I'm going to add the 30 over to the other side, and that's going to give me a plus 6 equaling 0. So I combined like terms and I added over the 30 because I needed the equation to equal 0. So looking at x squared plus 5x plus 6 equaling 0, the number in front of x squared is 1, so that's just your C method. So we need factors of 6 to add up to 5. Be careful with your signs. We can't use 6 and negative 1 because everything's positive. So the factors of 6 to add up to 5 are 2 and 3. So this is going to factor into x plus 3 and x plus 2 equaling 0. At this point you said each factor equal to 0, so x is going to equal negative 3 and negative 2. I'm skipping some steps, so make sure you realize the steps in between are when you take each factor and set each one equal to 0 and solve each one individually. Okay? Number 12. 12x cubed plus 20x squared minus 8x equals 0. So we do have the 0 on the right hand side, which is great. Now let's figure out how to factor this. Most of our things have been quadratic. This is not quadratic because we have a cube. So this is cubic. Well, first things first, we look for a GCF, and the GCF would be a 4x. So I'm going to take out a 4x from every term, and I'm left with 3x squared plus 5x minus 2, still equaling 0. At this point, the 4x is part of our GCF, which we factored out. Now we have to factor 3x squared plus 5x minus 2. The number in front of x squared is a 3, which means I'm going to have to do my AC method. So a times c is negative 6. I need the factors of negative 6 to add up to a positive 5. What would those be? Negative 1 and positive 6. So those terms get replaced into the b term. So we get 3x squared minus x plus 6x minus 2. Now we're going to factor by grouping because we have 4 terms. So between a 3x squared minus x, we see there's an x in common, and I'm left with 3x minus 1. Plus, what's in common between a 6x and a 2 is a 2, so I'll take out a 2, and I'm left with 3x minus 1. Again, if what's in parentheses is not the same, you've done something wrong, but it is the same, so I'll take out the 3x minus 1, and in parentheses I'm left with the x plus 2. But don't forget you pulled out a GCF, so I need to bring down the 4x, and it's still going to equal 0. So make sure you bring that GCF down. So you'll see that we actually have 3 things being multiplied, so we're going to set each one equal to 0. So either 4x would have to equal 0, or 3x minus 1 would equal 0, or x plus 2 would have to equal 0. So for the first example, 4x equaling 0, I'll divide both sides by 4. When I divide by 4, 0 divided by 4 is 0. That is an answer. 0 we like. Don't throw it out. We add over the 1 for the second equation. 3x is going to equal 1. Divide by 3, so x is going to equal 1/3. Lastly, we'll subtract over the 2, so x would equal negative 2. So we have 3 answers, x equaling 0, 1/3, and negative 2. So lastly, we're going to work on something called the Pythagorean theorem. Just briefly, the Pythagorean theorem says if you have a right triangle, then the sides are in proportion as a squared plus b squared equals c squared. So the Pythagorean theorem states a squared plus b squared equals c squared. The side of one of them squared plus the side of the other one squared should equal the hypotenuse squared. So c is the most important, and c is the one opposite the right angle, which is the longest side, the hypotenuse. So in this example, c is going to be x. A and b, the either sides does not matter, so I'll just let x minus 8 be a, and I'll let x minus 1 be b. So it says find the length of the sides shown. So now we're going to use the Pythagorean theorem. So if a was x minus 8, it's going to be x minus 8 quantity squared, plus b was x minus 1, so x minus 1 quantity squared, and c was x, so I need to have x squared. Again, since I did a substitution, I use parentheses. Now, how do I do x minus 8 quantity squared? Well, that's when you have to do x minus 8 times x minus 8 and FOIL it all out. You're going to have to do the same thing with the x minus 1 quantity squared. It's x minus 1 times x minus 1. And the right side's nice. X squared is x squared. So if you multiply all that out, FOIL, combine like terms, you're going to have to fill in some steps, okay? Multiply it all out, combine like terms, and then bring over the x squared. You're going to end up with a 2x squared minus 18x plus 65. We'll leave the x squared for now over on that right hand side. So we get 2x squared minus 18x plus 65 equals x squared. We definitely want to make it equal to 0, so we're going to need to subtract the x squared over to the other side. So 2x squared minus x squared is just going to be x squared. So we get x squared minus 18x plus 65 equaling 0. So at this point, we do need to know how to factor. Factors of 65 add up to negative 18. What would these be? Those would be an x minus 13 and an x minus 5, because a negative 13 times a negative 5 is a positive 65. But if I add negative 13 and negative 5, I get negative 18. This was just a C method because the number in front of x squared was just 1. So now I'll set each factor equal to 0. So x minus 13 will equal 0. Or x minus 5 would equal 0. So now I get two answers. I get x equaling 13 when I add over the 13, and I get x equaling 5 when I add over the 5. So let's see which answer I keep. Do I keep both? Let's make sure. Looking at x equaling 13, that would say my hypotenuse was 13. That works. If I plug in x where the x is for a, I get 13 minus 8. And 13 minus 8 is 5. So that's okay. And when I plug in for b, I get 13 minus 1, and 13 minus 1 is 12. So that one was okay as well. So my answer would be 5, 12, and 13. Now let's look at the other x value. The other x value I got was 5. So x equaling 5 is okay for the hypotenuse. But what happens if I plug it in for a? If a was x minus 8, and I plug in a 5, 5 minus 8 turns out to be a negative 3. Can a side be negative? Can a length be negative? No. So it gets thrown out, which means 5 has to get thrown out. So make sure when you do this problem, if you get two answers, you have to check both answers. We'll keep x equaling 13 because it was okay with the other sides. We can't keep x equaling 5 because it makes the other side, one of the other sides negative, which does not work.